Welcome to data analysis with Python. We're still on with the Capstone project. This is, I think, the fifth one. I'll stop um, with the next one, another Capstone project after this, and that'll be a wrap as far as data analysis with Python is concerned. But feel free to let me know if there's something else you'd like me to do on data analysis. After that, I should be moving to SQL, or what they call SQL with Python. I want to use SQLite in that regard. All right. And don't forget, you have access to all my code sheets, my data sets. If you check the description box, either on Facebook or on or on YouTube, you have access. So just click on the link and you can download all the materials I've been using on data analysis with Python. Okay. So here we are looking at a capstone project on neighborhood resource equity dashboard. Here, since we've learned already that we could use Plotly, we could use Bokeh for dashboards. Here we're focusing on Plotly. The next one I'll be using Bokeh and like that. So the introduction here is that uh, this dashboard built using Plotly and Dash. We have Plotly for data visualization and Dash for dashboard. It provides an interface to explore neighborhood resource and equity metrics through dynamic charts and tables. Okay, so the first thing we want to do is to import the libraries. So we're importing pandas to load and manipulate the CSV data. We're importing Dash to for core Dash app framework. Then we from Dash we are also importing dash.dcc, which is Dash core components like drop downs and graphs. Then we have dash.html, that is HTML coming from the Dash library for creating HTML layout elements. Then we have dash underscore table still coming from Dash itself for creating an interactive table. Then we have input and output, which are used for callback functions. Then we have plotly.express, that's where plotly comes in now. And we also have plotly.graph objects for creating plots like bars and radar charts. So the next thing we are doing is to load the CSV file. Well, like I always say, right, in my folder, I have a CSV file named neighborhood resource equity. So we can see that in my folder for, yeah, so we have neighborhood resource. Oh, where is that? Neighborhood resource equity. So I'm always a fan of checking the original file, especially if you're seeing it for the first time, see what it looks like. So you can have an idea of what you want to do. So here we have columns like neighborhood, education score. I mean, we could actually give specific neighborhoods. If you have actual neighborhoods, you want to work with that. So we want to have so it's more like we have different neighborhoods, probably in a county or in a in a more like in a ward or something like that. And you want to see maybe you have this scoring to tell people if they need to get an accommodation or something like that. So they can just quickly come to this dashboard and see which neighborhood are top five, which are the best neighborhoods as far as healthcare is concerned or for housing quality and things like that. And then we have an average equity score at the end of the day. So the equity score is an average of education, healthcare, transportation, housing quality, and green space score. All right. So we have all that. So how many neighborhoods do we have? We have 120 neighborhoods. That's 120 data points. And then one, two, three, four, five, six, 7 columns. From my first inspection, the data looks clean. There's no need for cleaning up anything except, yeah, okay, we don't also have dates, so we don't have to worry about dates. So, uh, we don't want to need to load the CSV file like we've seen. And of course, okay, I forgot to run this. We're going to have an error without me running this. So I press Control Enter and I run that. Make sure the cursor is inside this cell before you run. So now that you have number one, that means that has been run. Then we can move on to the next because pandas has been installed, has been imported here. So we can use it here to load the CSV file. And as usual, we know read underscore CSV is the function we use in the pandas library to load a CSV file as you have it right here. So now, so we'll run this and visualize it. And then we see just what we've seen in the CSV file down there. So top five and last five. So we have the neighborhood numbers and the scores across different areas, and then the average the equity score at the end of the day, which can help in making decision about the best neighborhood to live in at any point in time. Okay, so the next thing I want to do is just some kind of exploratory data analysis. So I'm going to use two popular ones, df.info. Our data frame is df. So we've converted that neighborhood data set, which is CSV, into a pandas data frame. So we want to see an overview, which you already have an idea of, right? So here it tells us we have 120 entries, that's 120 data points with 7 columns, and they are all and the neighborhood is the only object there. Others are either integer or float, so you can do some maths with them. And then we can also do some things. Most of the columns are numeric in nature. So we can also see some statistical overview by using df.describe. So for education score, the least is 50, the average is 73, and the maximum is 100. Okay, some have up to 100%. No missing data, as you can see already, because all the counts are 120. Perfect. Then health score, the minimum health score is 51 and the mean is 75, the max is 100. So it means they are doing better in health care than education relatively. Then for transportation, the minimum is 51, the mean is 74, and the maximum is 100. Okay, for housing quality, the minimum is 40, so and the mean is 70, and the max is 100. So the average, on average, right, housing is across the neighborhoods is better than transportation, healthcare, and education, though the gap may not be that much, but overall, housing has been the least. And now we go for green space. Okay, green space seems to have displaced housing. When it comes to talking about average green space score, that's 63.7. The minimum is 30. Oh, that's even bad. And then somebody still manages, some neighbors still manage to have 100. Then the equity score, the average equity score across neighborhoods is 71.57. Okay, and the minimum is 52.6, whereas the maximum is 90. So if you now take these neighborhoods, maybe these neighborhoods are in a particular ward, and then you go to another ward, and you can also compare to see, maybe you're in the city and you want to compare with the best ward to live in, and you have this kind of data. You can decide, okay, it's better to live in this ward than that, based on the average scores and all of that. Okay. So the next thing is we want to initialize the dash app. So, and to initialize, what we just do is, of course, this is a variable name, right? App equals, so this dash function now is from the dash library, and then to initialize, right, we have this double underscore, then name double underscore, and then the app title will be neighborhood resource equity dashboard. So what this does is to create a dash app instance and set the browser title. So if you run this, we just see it has worked, but there's no error and there's no result, because at this point you're not expecting any results. By running that, we have initialized the dash app. Then the next thing is we can create the layout. Okay, so to create the layout, we have all these lines. So for the layouts, you have app. Don't forget you have defined the app up here, right? So you say app.layout equals html.div. Don't forget we did some HTML mounting down here. So from dash now we're able to import HTML, and that helps us to force to that helps to create HTML layout elements. Okay, so it means this can be integrated into a website or something like that. So we have HTML.h1. So you have neighborhood resource equity dashboard. That I want to believe H1 is like heading one or something like that. So, and then the style, we align the text in the center. We have HTML.div, the div, HTML.label, select. So here you want to select neighborhood. This is your drop down. So from core components, dash core components, you select a drop down. So you use neighborhood drop down ID, and then the options, you have the labels, the values for n in the neighborhood, and you have to have unique values, no repetitions. And then the value will be whatever neighborhood you extract, you get from your selection. And then the style is, say, the width 40%, margin auto. You can work on this. Then we need, so this is the graph now. So see, we have a drop down, we have graph. So we have radar chart. We also have bar for comparison. And then we have HTML. The second one will be the neighborhood scores table. So that is where we get the data table. So we dash underscore date underscore table dot data table. So what the things in the data table, you have the columns, the column IDs, you have the data. So from the data frame, right, to dictionary, you get records, filter action, you have all of this. And then, of course, don't forget to run because as far as this place is blank, it's not run yet. So if you run this now, so it's done, right? Because the number has now shown there. So what this whole layouting does for us is to define everything the user sees on the page, and that includes the title, the drop-down menu for selecting a neighborhood. So you can see the title up here already, that H1. Then drop-down menu for selecting a neighborhood. That's what you see right here. That's from our line 7 or so. And then radar chart for selected neighborhood. That is what you see in line 14. Then radar bar chart comparing all neighborhoods. That's what you see in line 16. Then you have the interactive data table whose definition starts from line 18. And then this allows the user to select a neighborhood. The dropdown is populated dynamically from the CSV data. All right. And then, okay, the dropdown is from the CSV data. Uh, yep. Where's the dropdown now? Yes. Yeah, we have all that. Um, Yeah, you can also see like data is from the DF to dictionary, so you get the records from all that. Then it defaults to the neighborhood in the data set. The first neighborhood in the data set automatically is the first neighborhood, like the neighborhood one, right? With that, it's a 3.0 equity score. That's your default. That's how we do this. Except you want to now set something else as your default. So if you want to set something else as a default, where you do that is so where the default thing is happening is this iLock 0. So if you change it to something else, then it becomes, so whatever you change it to becomes the default, right? So the next thing is we want to do the radar chart callback. You know, in Plotly, we came across the idea of a radar chart. So you have something like a circle and you now have like a radar. So when it's all done, you see it again. So we want to have a radar chart callback. So we say at app.callback, the output, we need a radar chart figure. The input is neighborhood drop down value. So the drop down values will give you it will help to change the radar chart each time you select a neighborhood. Then you now have definition, define the function from line 7, update radar chart from selected neighborhood. Then you have the rows, you have the categories, you have the values. You know, the categories are all those 1, 2, 3, 4, 5 areas that are graded for the equity score. And now values equal row of cards for cards and categories, and then the figure you have go figure that graphic object or something like that in Plotly go dot fig dot add underscore trace go dot scatter polar. So scatter polar is what we use for radar chart, right? So you have the R values, that's the radius, I think, the angle theta, that's categories, then field to name selected neighborhood. Then have the layouts now. So you say polar is dict, radial axis, and you do all of those things, and then it returns the figure at the end of the day. So don't forget to run this also so that it can be okay, it can be there. So this is triggered whenever the drop down selection changes. So it extracts scores for the selected neighborhood and it plots a radar or spider chart showing the 5 resource scores like education, healthcare, green space, and all of that. Then it also uses a plotly.graph underscore objects, the scatter polar rather. And then so that's done, right? Yeah, it's run. Then the next thing we do is we also need a bar for comparison callback, right? Bar comparison callback. So we have at app.callback, the output is bar comparison figure, and then the input is the neighborhood drop down value. So the value automatically defines the bar. All right. So then you now define update bar comparison. So we have a function like that. So from selected neighborhood, I think we have selected neighborhood up there somewhere already. Yeah, selected neighborhood. I think we already have a data set like that. Selected neighborhood. Yeah, I think this is what we have around here. So, so from all that, we have a figure. Now we need a bar. So we plotly express dot bar. then DF, so you sort the values, right? According to the equity score in ascending or in descending order, because ascending is false. So X is the neighborhood, Y is the equity score. So you color according to equity score. And then you can use the color continuous scale viridis, which you can change to uh, I mean, a rainbow, whatever else you want to change it to. Then the title is equity score across neighborhoods, and then you return the figure, right? Uh, so don't forget to also run that so that it can be committed to the memory. So this is triggered on any drop down change. So once you do another drop down, so you have another bar. So it plots a bar chart of equity scores across all neighborhoods using Plotly Express. Okay, it may not necessarily change because it's the same value. The only thing that may happen is that if the if for instance you have some kind of real-time data, so as the data changes the bars will keep changing. So as soon as something changes, the bars will automatically change. So maybe a community can displace the other one. So if you connect this dashboard to a real-time data set and the values are dynamic, so it can keep changing like that. But if it is stagnant, you always have the same thing all the time. Then you have the color gradients, which emphasizes which neighborhoods are doing better. So you're going to have some kind of color bar. Okay, that has been committed. Also, bar comparison callback. So the next thing is the data table configuration. So so to get the data table configuration, we need to use the data table function. This big data table from the dash underscore table, which is the well, maybe in this case, now maybe this would be like a function, and dash underscore table is a module. And then for the table with IDs data table, we have the columns name, column ID, column for each column in the data frame, like that. Then we have the data that's DF to pick the record. So filter action, sort action, native, page size is 10. You can change that value. Then you have the style table and all of this. So, and you want to print the table, right? So we commit that. Oh, okay. The reason why I'm doing print here is because if I comment this out now, you see, it's going to give me so many things which are not helpful at this moment. Okay, they're really not helpful now, but we don't need to see it, right? So I can as well just do a blank print. Okay, I do a blank print so that that display is not necessary. So what you have done here displays the entire data set in a sortable and filterable table, and users can filter each column using input boxes, and you can sort by clicking headers, paginate through data, right? So now that all of that is done, right? We can then run the server. So the easy way to run server in Plotly is by using if double underscore name. You remember when we initialized the first time, right? It was this double underscore name that we started with. So it is what we are basically calling again now. So you remember, right? This is when we're initializing, we had app equals dash dot dash double underscore. So this is underscore underscore name, then underscore underscore. So that's the same thing we are calling at this point now. So we have if double underscore name double underscore is equal to main, then you can now run the app. So you app run and debug true. So you debug if necessary. So if you run this now, and then you have your dashboard. Okay. So by doing this, our dashboard is out. Okay. So, and we have this is the radar chart that we've been talking about. This is the equity score across neighborhoods. So, if you are dealing with dynamic data, as the data change, the neighborhoods will change. And then we have the neighborhood score stable, so it is in 12 pages. So you can this one shows you the first 12 uh columns, and then you can click and it keeps changing. So let's start from the radar chart. So for the radar chart, right, you can select a neighborhood to see what it is like. So in your case, instead of having neighborhood 1 to 120, you can actually have the actual neighborhoods, right? So in this case now, we have neighborhood 1, and and since Plotly is dynamic, you can point things around and see what's happening. So for neighborhood 1, the health score is 67, the transport score is 91, the housing score is 88, the green space score is 79, the education score is 90, like that. So you can do that, and then you can also come and change to neighborhood 2. So you see the radar chart automatically changes. We can scroll all the way down to, let's say we want to see the last neighborhood 120. So just click on neighborhood 120, and the radar chart also automatically shrinks. So, I mean, in a way, you can also say how well a neighborhood is doing by the surface area of the radar chart. I mean, that might be a nice way to see how well a neighborhood is doing. So obviously, this is neighborhood 120 now. Let's see neighborhood 119. Neighborhood 119 seems to have a wider surface area. Not guaranteed, but it looks like that. So, in a way, by just looking at this, it looks like neighborhood 119 is doing better. Then we come to equity score across neighborhoods, right? So here now, so the yellowest is the best, and the bluest, or would that be purple now, is the worst, right? So it means the best neighborhood is neighborhood 64. So they have the best equity score, followed by neighborhood 73. So the top five will be neighborhood 64, 73, 8, 1, and 66. And the worst neighborhoods are 68, 27, 117, and 77. So that can actually make you decide where you want to live. So some of the best places to live in this area will be the neighborhood 64, 73, 8, 1, 66, and 34, according to the equity score. Then, of course, you may also want to see the values if you are actually interested in the specifics. So you can come to the equity table. I mean, you can come to the data table, right? And then this is neighborhood 1 to 10. So you can scroll, you see 11 to 20. You scroll, you see 21 to 30. So you can keep going like that. So it's more or less like what you have in the data set before. So this is a very sweet dashboard. So, and the summary of the features is simply this. You have the drop down menu to choose the neighborhood. You have the radar chart, which shows resource scores for one neighborhood. So if you are interested in the specific neighborhood in details, you can see that. For you have bar chart, which compares equity score across all neighborhoods. I mean, that's a one-stop place to see how all the neighborhoods compare. Then you have the data table where you can sort and filter and view all data. Uh, Let me see. Are there other? Yeah. Okay, I think there are other levels of filtering we can have, right? So filter data. Okay, we can keep scrolling down and all that, like that. Okay, so we can also use that, right? Okay, so of course, another alternative, now I'm doing this in Jupyter Notebook, right? What if you really want to do an app or something like that? So another way you may also want to look at it is you have an alternative way to run where you save the code in a file, e.g. app.py or whatever you want to call that. I think the way to do that is also still here. So, if you come to file here, you can save a notebook, or you can even save and export as a Python file. How does that work again? Yeah. So you can save notebook as, let me see, this capstone project dot so this is IPMBY. So you need to save it as a normal Python stuff. So let me see. Yeah, I remember there's a way to do that around there. I've always saved in IPNBY, which is Jupyter Notebook. So you can always save as .py, which is a proper Python file. So once you do that, then you can save the code as whatever .py and make sure your neighborhood resource equity, the CSV document has to be in the same place where you keep this, just like I've been doing. And then you install the dependencies, which I've done already in this place. So pip, install dash, plotly, and pandas, all these things we need. And then you run the app by just maybe at the command line. So I mean at the terminal also. So you can run this. And then this is another way to run. But of course, in Jupyter Notebook, we've done this already. Okay, so that's how this has been talking about a dashboard for neighborhood resource equity. So it's interesting. You want to go over it again and be able to implement it. So you can get the code sheet and the data set, of course, by looking at the comment at the description either on Facebook or YouTube. If you have subscribed to this channel, of course, you've been getting a lot. If you have not subscribed, you don't want to miss out on what is coming after now. I still have one more dashboard to do, and then I go to SQL with Python, right? Talking about SQLite and all that. So subscribe, hit the notification bell so you can always get alerted anytime any video is released. Let me also know how helpful these videos are for you. And if there's a kind of data set you'd like me to work with, feel free to let me know. Be sure to like and share also so that more people can have access to this great content I have on here. Till I come your way again, keep doing data right. Bye.